In the grand hall of science, few names resonate with as much genius and influence as Carl Friedrich Gauss. Often hailed as the prince of mathematicians, his mind reshaped our understanding of numbers, space, and the very fabric of the cosmos. From the day he corrected his father's arithmetic at the age of 3, it was clear that Gauss was no ordinary child. This is the story of a mind that saw the world in patterns and equations, a journey through the life and legacy of a titan of intellect. How did one man contribute so profoundly to so many fields? Join us as we explore the incredible story of Carl Friedrich Gauss, a man who didn't just study the universe, he calculated it. Gauss was born in 1777 in Brunswick, a city in what is now Germany, to a family of modest means. His father was a labourer, and his mother, though illiterate, recognised her son's extraordinary talent from a very early age. The most famous tale from his childhood is the story of his primary school teacher who, wanting to keep his students busy, asked them to sum the integers from 1 to 100. While his classmates toiled away, a young Gauss found a shortcut. He realised he could pair the numbers. 1 plus 100 is 101, 2 plus 99 is 101, and so on. There were 50 such pairs, so the total was simply 50 times 101, which is 5050. He allegedly wrote the answer on his slate and placed it on the teacher's desk within seconds, astonishing everyone. This was more than just a clever trick. It was a glimpse into a mind that naturally sought out elegance and efficiency in mathematics. Recognizing this prodigious talent, his teachers and local patrons, including the Duke of Brunswick, provided him with the financial support to pursue his education. This was a crucial turning point. Without this patronage, the world might never have witnessed the full scope of Gauss's genius. At the age of just 15, he was already making groundbreaking discoveries, venturing into the uncharted territories of number theory. He proved the law of quadratic reciprocity, a deep and fundamental theorem about prime numbers that had eluded the greatest mathematicians before him, including Euler and Legendre. He called it the Golden Theorem, and it became a cornerstone of modern number theory. By the time he was 21, he had completed his magnum opus, Disquisitiones Arithmeticae, published in 1801. This book was a revolution. It systematically organized number theory, introduced the concept of modular arithmetic, the math of clocks and calendars, and laid the groundwork for algebraic number theory. It was so dense and advanced that it took decades for the mathematical community to fully appreciate its depth. While his work in pure mathematics was enough to secure his place in history, Gauss's curiosity was boundless. He soon turned his gaze to the heavens. In 1801, the scientific world was in a frenzy over the discovery of a new celestial body, Ceres, which appeared to be a planet orbiting between Mars and Jupiter. But after just a few weeks of observation, it disappeared behind the Sun. The problem was, with so little data, astronomers couldn't predict its path to find it again. It seemed lost forever. This is where Gauss stepped in. He took on the challenge, developing a revolutionary new method for calculating orbits from just a few observations. This technique, now known as the method of least squares, is a fundamental tool in statistics and data analysis used every day across countless fields. Using his calculations, Gauss told the astronomical community exactly where to point their telescopes. And in December of that year, they found Ceres, right where Gauss said it would be. This achievement made him an international celebrity overnight. He wasn't just a theoretical genius, he was a practical problem solver of the highest order. This success led to his appointment as the director of the Göttingen Observatory in 1807, a position he held for the rest of his life, but his work didn't stop at astronomy. The early 19th century was a time of great exploration and cartography, and Gauss became involved in a massive project to survey the Kingdom of Hanover. This wasn't just about drawing maps. For Gauss, it was an opportunity to investigate the very nature of space itself. He spent years trekking through the countryside, taking meticulous measurements with a device he invented called the heliotrope, which used sunlight to send signals over long distances. During this survey, he began to question one of the most fundamental assumptions of mathematics, Euclidean geometry. For 2,000 years, everyone accepted that parallel lines never meet, and that the angles of a triangle always add up to 180 degrees. But Gauss wondered, what if they didn't? What if space itself was curved? He secretly developed the foundations of non-Euclidean geometry, a concept so radical he feared it would be met with ridicule. He wrote about it in his private notes and letters, but chose not to publish his findings, fearing he was too far ahead of his time. Years later, mathematicians like Beaulieu and Lobachevsky would independently publish similar ideas, forever changing our understanding of geometry and paving the way for Einstein's theory of relativity, which describes gravity as the curvature of spacetime. As if revolutionizing mathematics, astronomy, and geometry wasn't enough, Gauss then turned his attention to physics, specifically magnetism. Working alongside the brilliant physicist Wilhelm Weber, he made incredible strides. In the 1830s, they invented the first electromagnetic telegraph. They successfully sent a message over a distance of more than a kilometer, connecting Gauss's observatory with the Physics Institute in Göttingen. While other inventors would later commercialize the technology, Gauss and Weber's device was a pioneering proof of concept. They also conducted extensive research into Earth's magnetic field, organizing a worldwide network of observatories to collect data. This magnetic union was one of the first international scientific collaborations. Gauss developed mathematical tools to analyze this data, creating the first comprehensive model of the planet's magnetic field and precisely locating the south magnetic pole through calculation alone. The unit of magnetic flux density, the Gauss, is named in his honor, a testament to his foundational contributions to the study of electromagnetism. Throughout his life, Gauss was known for his motto, Poca sed natura, which means few, but ripe. He was a perfectionist who refused to publish work until it was absolutely complete and without flaw. This meant that many of his incredible discoveries remained hidden in his personal diaries for decades, only to be found after his death. His notebooks reveal he had anticipated discoveries that would later make other mathematicians famous. He had explored complex analysis, elliptic functions, and even non-Euclidean geometry long before they became mainstream topics. Some historians argue that if he had published everything he knew, he could have advanced mathematics by 50 years. But Gauss wasn't interested in fame or priority disputes. He was driven by an internal quest for perfection and a deep, personal connection to the beauty of mathematical truth. He preferred to build complete, unassailable structures of logic rather than simply plant flags on new territory. Gauss was a private man, deeply devoted to his work and his family, though his life was marked by personal tragedy. His first wife, Johanna, whom he adored, died young, and the death of one of his children plunged him into a deep depression. He remarried, but his relationship with his second wife and some of his children was often strained. He could be seen as austere and conservative, a man who found more comfort in the predictable certainty of numbers than in the messy complexities of human relationships. Yet, he was also a man of integrity, a loyal subject to his patron the Duke, and a demanding but respected teacher. His dedication to science was absolute. He worked tirelessly until the very end of his life, his mind as sharp as ever. Carl Friedrich Gauss passed away in his sleep in 1855. At the age of 77, he was buried in Göttingen, the city where he had spent nearly half a century unlocking the secrets of the universe. So what is the legacy of Carl Friedrich Gauss? It's almost impossible to overstate. He is a central figure in the history of science, a bridge between the classical mathematics of the 18th century and the abstract, complex world of modern mathematics. His work in number theory remains fundamental. His method of least squares is an indispensable tool in our data-driven world. His quiet exploration of non-Euclidean geometry opened the door for Einstein's universe. His contributions to magnetism helped usher in the age of electronic communication. Gauss's influence is woven into the very fabric of our technological society. From the GPS in your phone, which relies on principles of geometry and orbital mechanics he helped develop, to the statistical models that drive finance and medicine, his intellectual fingerprints are everywhere. He wasn't just the prince of mathematicians, he was an architect of the modern world. His life is a powerful reminder that the relentless pursuit of knowledge, driven by pure curiosity and a commitment to perfection, can change the world in ways we can barely imagine. Thank you for joining us on this journey through the extraordinary life of Carl Friedrich Gauss. If you enjoyed this exploration of one of history's greatest minds, please hit the like button and subscribe for more stories from the world of science and discovery. Let us know in the comments which scientific pioneer you'd like to see us cover next. Thanks for watching.